Today we are evaluating the algebraic equation m times m times m plus m equals 10. We will calculate the value of the variable m. Simplify the first term of the equation. Multiplying a variable by itself 3 times is equivalent to raising it to the third power. Rewrite the expression as m to the third power plus m equals 10. Now let's rearrange the cubic equation into standard polynomial form. Subtract 10 from both sides of the equation to set the entire expression equal to 0. This yields m to the third power plus m minus 10 equals 0. Decompose the constant term negative 10 into parts that align with perfect cube numbers. Express negative 10 as negative 8 minus 2. The equation becomes m cubed plus m minus 8 minus 2 equals 0. Graph the cubic terms and the linear terms together. M cubed minus 8 plus m minus 2 equals 0. Convert the constant 8 into exponential form. 8 is equal to 2 cubed, which rewrites the first grouping as a difference of cubes. M cubed minus 2 cubed. Apply the difference of cubes algebraic identity to the first factored block. The expression m cubed minus 2 cubed expands into the quantity m minus 2, multiplied by the quadratic quantity m squared plus 2m plus 2 squared. This updates our equation to m minus 2 times m squared plus 2m plus 4 plus m minus 2 equals 0. Identify the greatest common factor across both groupings, which is the binomial m minus 2. Factor out m minus 2 from the entire expression. This leaves m minus 2 multiplied by the quantity of m squared plus 2m plus 4 plus 1 equal to 0. Simplify the second polynomial factor by combining the constant numbers. Adding 4 and 1 equals 5. This yields the completely factored equation m minus 2 times m squared plus 2m plus 5 equals 0. Set the first linear factor equal to 0 to find the real root. For m minus 2 equals 0, add 2 to both sides of the equation. The primary real solution is exactly m equals 2. Now let's check the second factor m squared plus 2m plus 5 equals 0 for any additional real solutions. Apply the discriminant formula. Discriminant equals b squared minus 4ac, where a is 1, b is 2, and c is 5. Substituting the coefficients yields 2 squared minus 4 times 1 times 5, which reduces to 4 minus 20. The discriminant is negative 16. Since it's less than 0, this quadratic factor yields no real solutions.